Okay, I'll start recording. Just wanted to say a few words before giving the word to Professor Wu. In this class, we are using as a platform to support our projects a cloud environment, and it's moreover is which is Bluemix. So you are learning hands-on two different things. Learning the tools of big data analytics in different levels. In addition, you are learning them in form which is cloud as a service, which is Bluemix. So the two technologies together help you. Of course, it's a little not exactly if you are using the technology without the cloud environment, but you have to be aware that there should be some differences. It's not saying that your team have the Hadoop system in your company, or you are going to use this as a service in the cloud. So take this opportunity and enhance your professional experience, and you have to be aware that this is a service which from time to time we will have interruption of the service, like when we need to update, to upgrade all this. And take this as a part of the training for your future professional career, because this is what is the future. This is what you are going to find in your company. With no more, I'm giving the word to Professor Wu. I think the control to you, so you can share your screen, and you're going to tell them. 2 questions. Just make sure you unmute yourself. Okay.
Thanks, Professor Kurcheva. Okay. Oh, cool. Let me start with the brief introduction to Hadoop Big Data, and I'm gonna briefly introduce the Spark transformation. One of my slides that I put in the note should include the same content as I have now, that I'm going to share now. Sharing the screen now. So I believe you can see my screen now, right? This is my cool. Yeah. So it's my screen. Let me to another screen. Okay. Let me just start with this one. We live in the era of a large-scale data set, definitely byte or petabyte. Definitely, or hundreds of gigabytes are also large-scale data set, and it is mostly from the we are using. Also, data that is actually recently we call it IoT, that is Internet of Things. Also, bioinformatics data and social computing data such as Facebook, LinkedIn, Instagram, etc., and smartphone, text from your smartphone, also your geo information collected by companies, even though you don't recognize it, and also generate too many streaming data set. This large-scale data set is not easy to get handled by the legacy approach because it is too big, and those data are not structured or semi-structured data set. Actually, it can be handled. When I handled, it means that using the traditional approach, we can definitely handle that, but the problem is it becomes too expensive. If you use database, for example, it becomes $1 million to store and compute those data. So it's tougher. So actually, we need new systems, and the Google had that problem, people and other companies. So really, when started the business to collect data set from all around the world through the web robot, they found the issue to store large-scale data set and also to compute those large-scale data sets. So on system called WebFS, that is Google Systems, on inexpensive commodity computers, like Linux servers, they could store large-scale data set in distributed system approach. If you store those data, you could compute the big data, those data sets on Google's Mavis approach. Readers also run in parallel based on those inexpensive quality computers, and it means that Google actually built it on supercomputers, because supercomputers is actually parallel computers. It is composed of thousands or some tens of thousands of servers. But the point is, this is not expensive computers. Also, those actually run in Linux operating system. That is And around 2004, the Google published a paper to show up what it did. So, based on that paper, Hadoop quality has been started by the founder of Hadoop. That is, this is the picture of the founder of Hadoop. He's Doug Collins. Actually worked at Cloudera as a chief architect. And the Hadoop, you will see the yellow elephant. Collins' son's toy named Hadoop. That is actually elephant toy. So there we see the elephant whenever we see Hadoop and its ecosystems. So when you define big data, actually that is a non-expensive framework that can store a large-scale data set. Also, in parallel. That is so. If we just see, it sounds like there is a large-scale data set, but it's not all. We also, that is actually a system that can store the largest set, and it processes it, and also it shouldn't be expensive. That's why I started using the Hadoop system, because that is all free. So any small company or school or research lab, they can have their own supercomputer. So this is a simple picture to show how you can build your own Hadoop systems. We have just 9 nodes here, and there's one single node that is to monitor the 9 nodes. But you have 4 computers or 2 computers. You can build your own Hadoop systems. But the that we're using now is actually a cloud computing that is built by IBM. Because if you build your own servers, you actually need to spend your time to manage the servers that you like. That's why people some people prefer using cloud computing because they can focus on business logic instead of managing servers. So Bluemix use IAM and Microsoft Azure or Amazon AWS. Okay, so that is actually big data that I want to introduce. And also, recent people, the Spark has a bit high because everything that will replace MapReduce, Hadoop because Hadoop MapReduce has some limitation. Because for Reduce, you need a Java code to build map function and reduce function. That's easy. And also processing. So it's not interactive. And the bottleneck, especially when you generate intermediate data from member, should be stored into local system, not into hardware system. So IO, that takes actually a huge latency. And once it's written into disk, the user needs to read the intermediate data. So they're like there. And most kind of okay, but especially for machine learning is has a loop. So if you have a disk I/O issue, then you cannot get any benefit to running it in parallel. And you don't is not that fast in summer. There's a UC Berkeley lab, the app, been working on parallel systems. They had a kind of in-memory processing, and they realized that their system can be used for replacing MapReduce in Hadoop. And so the UC Berkeley, some members of UC Berkeley started a company called Databricks to start Spark project, and that is actually Apache Hadoop project, one of Apache project as a and benchmark, that is actually 20 or 100 times faster than MapReduce. So as I said, since it is in-memory processing, you don't need to write any routine into disk. So good for motions that people are interested in. You can still use Hadoop cluster, has Hadoop file system, and other ecosystems such as HBase, Hive, and Sequence files, etc. So the has been used for several years. So the companies they have their own Hadoop cluster. Kill it. They don't want to kill it. So once the Spark has been used, once the Spark can be integrated into Hadoop cluster, that should be amazing. People love it, and that's why I think they want to move it to from the MapReduce. Spark has many libraries such as Spark SQL. You can use the syntax that is easy for data analysis. That's why at assignment 4.B we have a Spark SQL to show easy to use Spark in Bluemix. I'm sure most of you know SQL, so how easily you can use Spark with the SQL syntax. Spark streaming to interactively analyze streaming data set, learning library you're using for Aside 4.2. So even though that is very simple code, I just want you guys to their machine learning library that you can easily use. There's a related library, or Spark has SparkOwl. So once you know R, you can use SparkOwl to run your code in parallel as well as a process. Spark run on Hadoop cluster, so it has a client and workers, the Spark executor. So in your Hadoop cluster, run map-tab and reduce task as Hadoop systems. But instead of doing that, you can run Spark workers, Spark executor. Task. That's IBM Bluemix is doing. So you see, this is master node that has a Spark driver, and this server node are like more nodes, more servers, right? And each has a Spark executor to run the flow of the fundamental data unit that equivalent to blocks or MapReduce, and it has a lineage. It means that if you have two data sets that can be to generate new data set, then lineage data set is actually generated from this existing two other data sets. So if new generated data set is killed or corrupted, then Spark can automatically go back to the parent data set to regenerate the new data set. This is very good the prop to keep data reliability. LBD has two main operations. One is transformation, second is action. Transformation is such as map function, filter function, and join function. That is based on lazy computation. Each transformation function, each the RDD, but they are not kept in RDD yet. So what that data is actually generated in RDD is when you call action functions such as count, collect, take, and save. So we call actions function. The transformation the inside the RDD. Several languages that can be used in Spark, such as Python and Java. Kind of a new language that is actually functional programming language. Takes parameters as a function instead of using variable. So they have a side effect. I'll mention more in detail about the side effect, but simply in parallel programming, the most important issue is to avoid the side effect, and the functional programming is good fit for all side effects to get result. All right, Python is another the popular language in Spark. Python is two times slower than Scala, but Python is more popular than Scala in Spark world. It is because Python has been used for several years. So it has any existing library. It has learning libraries and libraries to go chart. So easily write a code. So people prefer Python. That's why the assignment is all written in Python. There's another the language that can be used in Spark, but write Java code in Spark is very complicated. So simply say Python is ready to go over years from now. Running on top of Java. I don't want to show you any detail. This should be good enough for introducing the Bigtable, Navidos, and the Spark. So let me move it to let's show you just in case for ones who never use it, for Spark, you can just simply go to Bluemix, console.ng.bluemix.net, and then to catalog, and then many services, but there's a boilerplate, and Apache Spark Starter is the thing that you need to start. So okay. Type in the space that you're using. You can type in any name, data, 650, or name like AW or something. Click create. But before you do this, actually you need to create a object storage. If you take a look at the actually step-by-step direction that shows how you can create object storage that is actually for storing files. So if I go back to catalog again, there is storage. If you click on it, there is an object storage that is actually IBM beta version. So it is free. So you click on it, create the object storage. So you can type in, if you like, and it of 5 gigabyte. You can so actually the cloud computers such as IBM Bluemix and Microsoft Azure, the compute servers and storage servers different from standard hardware system, because each server should have both computing and storage function. But cloud computing, they separate the compute node and storage node. But to avoid the latency, IBM and Azure, Microsoft Azure, they use real high-speed network to connect storage and the computers. That's what you may want to take a look at, because I ask you that kind of question. So once you follow it well, you will see, for example, this is my Apache Spark that is connected to object storage that I created, and there are two areas that you may want to take a look at. One is many files. So if you click on these files, you can see what folders and files exist on your object storage. And if you click on launch, that is to show you what kind of start. So that is the name of IPython notebook to really write a Python code in Spark. So let's start the manage files. If I click on it, files here, especially in climate data tutorial folder. Two files. One is 2015 CSV file. That is that is a file just for testing your Spark code. And I have another file, 2015.csv. That is 91.7. But I think Kate mentioned, one of your friends, Kate, told me that we downloaded this file and has more data. So she has about 800 megabyte data set. So you start your work, you have to make sure you download these two, especially 2015.1.csv file, to test if your code works well. So again, you want to launch to see. It may take time, but I'm really sure it's going to work. Let me log in. Sometimes it's not working. It takes time. So we click on it. Then we see the tutorials. And one of the tutorials that you need to download and upload it to here, because if you click on upload, you can select any files that you have. The Python file you download from the assignment page. So, for example, if I click on Python data analysis, this is the assignment 4.1, and you will see your code here. I click, you can see I click the page that is actually called the cell. So I cell 1, cell 2. So after I select the cell 1, if I click on play button, then it has been executed. And if I again, next cell has been executed. Execute. So here I click on play, it actually should be executed to calculate the data. How many rows exist here in 2015.csv. So actually, the assignment that I gave you is very, very easy, because I assume that this is your first time to Spark. So you can follow the step-by-step direction and see output. So it's very, very easy to play Python, I call it PySpark. The PySpark code here in Twitter on IPython notebook. So once you run it, you can run it and you can see immediately. So you press play button, and then the IBM actually has changed the Spark version to 1.4. So the original code, of course, function like I said, the Parquet file, but you see the error messages, so you can comment it out, and the message will say the Parquet file doesn't anymore, so we have to use the write.parquet function. So you can simply replace the write.parquet Parquet, then I can save it into object storage. Actually, that should be our system. And what you have to remember is, once you save it, you cannot read it again. Because, the file system is write once system. It means that you can the one time. After that, you cannot update it. So it and write again. So it is called the write one. There is, file system. I mean, Hadoop system is for data analysis, not for transaction. So a large scale data into Hadoop file system, you need to use it. You need to analyze it. That's, you cannot rewrite the file or you modify. So and you have to delete the existing file, or you have to rename the file alpha file name. Like I said, Snow Station 2, because I already have a Snow Station. So you need the Parquet file. Instead of using existing Parquet file, you need to use redo the Parquet file that you can see from the app if you run it. But Parquet is the file. It's based on column-based. That is stored in column way to speed up the file. So of the file system to speed up the writing and reading the data. So you can do 4.2 assignment 4.2. Daily use machine library, but the PySpark code into the system into here. So you really need to upload your notebook file, machine learning file, and assignment 4.2 file. And if you're going to, for example, you click it, that's the moment that the PySpark code starts running. You will see the icon become green. It means it is running, like this. It's running. That's why the icon becomes green. And sometimes, if you click shut, you just click on the orange button here, shut down. Let me see. Okay, go back to, let me see. Allow to the review. Can I go back to the WebEx main view?
Share screen anymore?
I don't anymore.
Just I don't know how to explain. You're right. Okay, anything to show. So anyway,
okay,
we
cool.
will go to the question. But
Sure.
before the question, you will want to show something, and I will pass the control to you. So we're going to the question now, right?
Yes, please ask me any question if you have.
Okay, you mute yourself or post your question in the chat.
So if you have any question, for Spark or Hadoop, Big Data, or assignment, please, can you show us the final cell results that you like to see? It is very easy. Number may be different because I know you have that than I have. Maybe the number becomes different, but it's okay. Don't worry about it because in the beginning you said that right. So I have a 500 megabyte file size. You have 800 megabyte file size. So it's even though number is different. Your Python notebook also show you the result code already.
Here, do you see the question in the chat?
Yes.
Okay. Okay.
Yes, and it's not the hard question because I assume that this is your first time to see the Spark. So I just want you to know how to open the file, how to run it, and how to see the output. And replace very small part of the code to read new data sets. Each step, I don't need all results of all cells. I want to see, for example, in the question, I would say at step 7, you need to take a screenshot. Then the 7th cell. Screenshot for all other cells. Only that part I want to see. So just set out before the Parquet cell. Any other question? It's great for you guys to understand clearly what is Hadoop, what is data, what are the ecosystems, and Spark, and why is it, and what is the object storage. So if you have any questions, feel free to ask me.
Here one question, but it's not directed to you, is what is the difference between Hadoop distributed file system and an Apache Spark object storage?
Again, the storage is not for Spark. Object is for computing. So if you build your Hadoop cluster using Clara CDH or Hotos HDP for Linux servers, then there is single a Hadoop cluster, and each Linux server should have speed, running, and other file system inside. So single server has both function and storage function. Things such as Bluemix and the Microsoft Azure. Their system, summary system do it. So they create the compute server and storage server, and servers and storage servers with speed network, speed switch. and they call they call store server as an Objective-3. But it works exactly the same as a file system and Medus or Spark tasks all together. It's clear. Actually, I answer.
Yes, the answer is yes. Nick, please direct your question to everyone because I'm receiving them. That's
Yeah, fish. You know, I've been working on this bigger the industry for since it started. So this is really a good opportunity for you guys to ask me any question to clearly understand what is Hadoop and what is Spark and what other. Sandra. Yeah, I actually learned. I took their training. You know the arrow things. They actually took it really has sensors and generate data second or every minute. So only it becomes large-scale data set. So using Hadoop, we can store those large-scale data sets in the file system, and using MapReduce or Hive or Key or Spark, we can analyze the data to see what is the pattern of temperature, room temperature, building temperature. That's what we are doing in assignment 4.2, assuming that we have a data from sensors to the building temperature and to predict our air conditioner is working well. But because the NoSQL database and what name data. Anyhow, thank you. So there is a NoSQL DB, and it has its own syntax to build the code, like similar to SQL syntax. What we are doing is similar what Hadoop and Hive and Keybase are doing. Difference is the syntax to write the data. Okay, Spark streaming is one of the Spark libraries. Yeah, the two compute streaming data set actually need to generate a streaming data set and take view of the streaming data set easy and just can that's why we just use batch processing. We collect the data set and into Hadoop file system and then Spark especially Spark machine learning library, we analyze it. But in Spark String library, we can interactively analyze the data from sensors. What difference between Spark Streaming versus Apache Storm? As far as I know, the Apache Storm uses built by Hortonworks. That is based on MPP. The MPP system. MPP is a massively parallel processing system. There is traditional parallel processing to handle the data stream data. I mean, data. So the motivation is the same, but the is different. So streaming is in-memory processing, and Storm uses MPP systems, but the same to compute streaming data set. But as we do in 4.2, you can fully, I mean, you have a data kept in HDFS in the beginning, or when it is generated, you can interactively analyze it. So Spark is just, I mean, again, the Kate, you need to think two cores in big data systems. One to store data, another one is to process the data. So it's actually a part of a processing data set. Spark is not related to store data. To be stored into a hard file system, and then it should be processed by Spark or Abletus. What the data set we are working on is kind of unstructured data. Actually, it is semi-structured data set. It's kind of people call it unstructured data set as well. But go to the Apache website, text processing to words, to file n-grams. That is to process unstructured data text. In the table, like many different systems have different terms. So tuple is like enable, you have a record, right? So tuple is like a simply collection of, like a table. Oh, metrics. Metrics is like I don't know name, but you could say metrics is like a data frame or table or bank. Sure. Other question?
I don't see more questions. Just wanted to stress that if you want to go beyond the assignment 4, it's optional question. If you want to do your own data set of your own machine learning model, you go ahead. But in order to be able to do it, it has to be in the frame of the class, because after that, this Spark Starter is going to change. So keep in mind. And of course, and also the course is over in the 28th. So keep in mind that we are already in week 8 and there is not much time for this.
Other question? And before, like Java has been popular as a programming language, but because of the big data, two data scientists or data analysts first started learning Python, because Python a good tool and library, and also can be used in Spark. Data scientists or data analysts is the thing you need to learn. And actually, there are many people who know Spark, so I'm pretty sure this is really a good opportunity for you guys to do the assignment.
I would like that I highly suggest you take as soon as possible this class. All this technology, as you see, change constantly, but having more deeper knowledge in what is now state of the art in this subject, which is Spark, is wonderful for you as a professional. So my suggestion is do as you can, and here in this class you can get advice and help to go beyond the required assignments.
What do you mean?
Yes. What asking is about the research is Flat City rather than academic journal. It's because it's research in the state-of-the-art technology. There are some journal paper, but only few of them. So it is fine. Just do the citation and try to find the most, let's say, serious resources in the web. Other than that, yes.
And other students?
see we don't have more questions. I hope this is helpful to everyone. And keep working. Don't all this assignment, let me tell you, each of them, these are 3 parts. You have to schedule at least 20-something hours a week. But it doesn't work to work just 24 hours non-stop without sleeping. This type of assignment which require, let's say, sleeping on the idea. So you cannot do this in a single day. Please schedule accordingly your time, and you will be more successful and don't get frustrated at the last moment. I think we don't have more questions, and we are ending this today. And just if more happening.
Thank you, Anna, and thank you, everyone. And if you have any questions, just feel free to ask me in the discussion or Q&A.
Bye, everyone.
Bye, everyone.